Both are exposed to hot air blasts from front center. The temperature of the GAINA coated plate starts to rise immediately and indicated by thermography. The temperature of the GAINA coated plate continues to rise while the plate coated with regular paint just started to heat up. After the air blast is switched from hot to cold, the temperature of the GAINA coated plate drops significantly, showing GAINA's ability to adapt to surrounding temperatures. Both plates were heated. The ice cube on the plate coated with regular paint starts to melt soon. The ice cube on the plate coated with the GAINA has not changed. The ice cube on the plate coated with regular paint has completely melted. The ice cube on the plate coated with GAINA stays ice. Holding it with both hands. Compare the temperature of the palms of both hands. The temperature of the palm which touched GAINA coated side didn't fall. The temperature of the palm which touched the regular coated side did fall. The leftmost drum is applied with GAINA. A to C drum surfaces are applied with the other company's insulation paint. The surface temperatures of the drums are compared using thermography. The drum surface where GAINA is applied indicates a lower temperature than that of A to C. GAINA possesses a property to assimilate its temperature with the atmospheric temperature and suppresses heat transfer to the minimum. Incandescent light is used to simulate the sunlight. An experiment is conducted using brand new iron plates on which the other company's heat-resistant paints are applied, and an iron plate, worn out after 10 years of use in experiments, on which GAINA is applied. Thermographic comparisons are made among the temperatures of the iron plate surfaces heated by an incandescent bulb. The surface temperature of the iron plate with GAINA applied is less prone to rise. GAINA is more effective and its effectiveness is longer lasting than the heat-resistant paints of competitors. Another experiment is performed to find out whether styrofoam fragments will attach to the celluloid sheet surfaces after the sheets are rubbed 10 times with a towel. The sheet absorbed 103 pieces of styrofoam fragments. A side view reveals that static electricity is attracting dusts. The sheet with GAINA applied absorbed no fragments. A side view shows that no effect of static electricity is seen. Adsorption of odorous substances such as cigarette smoke or of dusts floating in the air is strongly affected by static electricity. Because the electrostatic propensity of GAINA is zero, it is not affected by static electricity and less likely to attract pollutants. Boiling water is poured into a tin can whose surface is painted with GAINA, and the changes in temperatures are observed after touching the surface with a hand. The surface is touched with the bare hand. An image of a trace of hand can be observed on the surface of the tin can when you release the hand. The image of the trace soon disappears and the surface temperature rises closer to the temperature of the boiling water. This experiment can be viewed as a test of its scald prevention property. As the GAINA painted surface adapts to the temperature of a hand, scalding will not happen even touches the surface of a tin can with boiling water in it. The right one is applied with GAINA. The differences in noise levels are compared by striking the frying pans. GAINA forms a multi-layered structure of porous ceramic balls. Noises are reflected by ceramic balls and absorbed by the air.